Afternoon, everyone, and a very warm welcome to all of you. I'm Shiney, and I'm very happy to be your host today. Today is a very special day for us at MyWebinar. This webinar it marks our 50th MyWebinar milestone. Since we started this webinar series, our goal has been simple: to share the database knowledge with the community. And we hosted webinars on multiple database technologies like MySQL, MariaDB, MongoDB, Postgres, TiDB, and AWS. And we are so happy to have you here for this landmark event. And for this webinar, we chose a topic: securing MySQL 8.4 LTS data at rest encryption. In this webinar, we are specifically going to look at how native encryption capabilities have evolved in the new MySQL 8.4 LTS compared to 8.0, specifically for the Community Edition. So to lead this 50th webinar, I am joined by my colleague, Praveen GR. Praveen is a seasoned database consultant here at MyWebinar, and he has deep expertise in MySQL security and performance tuning. And a quick note to all the attendees: we are recording this webinar, and we will have a live Q&A session at the end. So please drop your questions in the chat throughout the presentation. So let's get started. Praveen, the floor is yours.
Yeah. Hi, everyone. Good afternoon. So, myself, Praveen, I'm working as a database consultant in Mydbops. So, today we are gonna see about how to secure the MySQL using encryption. So already Shiney has given a detailed introduction about MyWebinar. So I'm skipping a couple of slides. So before we get into the how to encrypt, first we need to understand why we need to have a encrypted data. Because if anyone got the host level access or the backup or the partition snapshot, they can easily retrieve our data. So because data is so sensitive in day-to-day lives, if the data breach has been happened, it's a huge impact to the business as well as the reputation. So to maintain it, we need to ensure that the data is fully protected. So if any one of the directory or if the snapshot or backup is exposed, they can restore it on a different machine, and they can able to spin up a machine from that and retrieve the data from that. So to avoid all these kind of data breach, we need to encrypt the data on the server. So by this encryption, we can able to encrypt the data files as well as the log files. It's not like the encryption can be done only for the data files present on the directory. We can even enable the encryption for the log files, as well as this encryption doesn't require any modification from the application side. So from the application side, there is no key or some extra configuration need to be done. There won't be any changes is required. It can be because the encryption as well as the decryption will be done at the memory level of MySQL. So when any data is going to make writes, it will be get encrypted at the memory level, and it will be get stored at the disk. And when we are retrieving the data, it will get the data from the disk unencrypted and shared to the end application or the user. So there won't be any changes will be required from the application side for enabling the encryption. And during to enable the encryption, first when we are enabling, it will generate a master key. Using that master key only, all the encryptions will be happening. So whereas each table will be having its own encryption key at its header. So using the master key, this table will be get encrypted, whereas the other log files and the like read log or unlock, all the logs will be get encrypted with the master file only. As I mentioned, the encryption will be handled on the memory level. So there won't be any changes will be required on the application side. And what are the places that we can encrypt means like the table space can be encrypted, the undo log, the read log, binary log, and the relay logs can be encrypted. And why we need to encrypt everything? Why can't we only go ahead with the encryption of the data files? Means even the not only the data files will have the actual data, whereas the underlog will, when the transaction is going on, the underlog will be generating the historical data to our rollback in case the transaction got aborted. Then even in that unlog also the data will be presented, and in the log also both like committed and uncommitted transaction will be available, which will be holding the actual data which is going to be applied on the disk. And bin log and the relay log, which is going to be have the fully committed records to apply it on the replica server or the secondary server. Even if any of these files has been data has been exposed, then the partial data breach is actually happened. So it's not like only we need to encrypt the data files, we need to encrypt the log files also. Why this is why the encryption is not negotiable? Like when we are handling a very sensitive customer data, we need to handle it very a secure way. If not, if any data breach has been actually happened, then the entire business will be affected. So we can't compensate about the data security. So even it's not like they need to gain the host access to get the data directory. Even from the snapshot, they can able to retrieve the data, or even like old backup also they can able to retrieve it. So it's not only about the host level access, even a place where we can't imagine they can retrieve the data, the sensitive data. How to maintain the keys which is used for the encryption. So once the master key is generated, yeah, that will be the main key which will be used to encrypt the individual tables as well as the log file, which need to be rotated on an interval basis, for every quarter, or based on the policies of the business requirement, we can enable the rotation. So by that the master key will be frequently rotated. Even if the key got exposed due to this rotation, that can be prevented. And the main criticality is if someone has been accidentally deleted the key file or removed it, then we can't retrieve the data. So the key file need to be maintained properly. In 8.0, we can able to enable the encryption by using the keyring file. So whereas in 8.0, we can run so plugins to identify that whether the encryption plugin has been enabled or not. So by further, we can modify the rest of the existing tables to get it encrypted. Whereas in 8.4, the way of enabling the encryption has been modified. So first we need to create a data file which will be actually storing the encryption key. and keyring file will be like this configuration file will be storing the path of the actual encryption file, and it will determine that whether it need to be in a read-only mode or read-write. So it is as a standard, it is recommended to maintain it at a read-only mode only, because no one should be able to edit that. And we need to mention a manifest file, which means in 8.0 we can mention it in early plugin to load it at the startup, whereas here in 8.4 we specifically need to mention the like manifest file. In that manifest file, the location and the corresponding paths will be mentioned to get it started at the service startup and shutdown. So once it has been enabled, so we can fire the query from performance schema to get the stats that whether the plugin has been successfully activated or not, like where the file of the location and what mode of encryption it has been enabled. Everything it will be we can able to get it when we are firing the query from key component status. So once the encryption is enabled, like either we can create the table with a statement of create table with encryption equal to y, which will ensure that all the upcoming tables are getting properly encrypted. Whereas the older table won't get encrypted automatically once it has been enabled. So we need to manually alter all the individual tables to get it encrypted. So this table encryption will take time based on the table size. So it is recommended to enable it at any non-peak time if the table size is higher, because it will lock the table to get it encrypted. And this default table encryption, we can enable this variable, which will ensure that all the upcoming tables are encrypted automatically, even though that create table encryption equal to y is not mentioned. So even though we didn't mention it, this variable will ensure that all the upcoming table creations are encrypted. Then for enabling the encryption for redo log and undo log, we have a dedicated variable for it. Once we have enabled it from the upcoming transaction, it will automatically start encrypting the the redo log and the undo log. So and it's a dynamic variable, so there won't be any restart is required for enabling the encryptions. And for same for a binary log and the relay log will be controlled by a single variable, like bin log encryption. So once we have enabled it, the bin log and the relay log will be automatically encryption will be enabled for it. Yeah. So to rotate the key, we can it's online, like there won't be any downtime as required to rotate the key. So we can schedule it at the quarterly once at non pure peak window to rotate the key. When we are rotating the key, the master key, all the individual table will be re-encrypted re-encrypted with the master key. So the re-encryption means it won't perform the alter again. So each table has its own encryption key, right, on the header. So that encrypted key will be encrypted with this master. So when we are encrypting, when we are rotating the master key, automatically that encryption key will be rotated for the each table. And also we have enabled the encryption on the server. So we need to take consideration of backup strategies as well. So because when we are taking a backup of encrypted database, the corresponding encryption key also need to be provided to have like backup. If not, the backup will be failing. So like it's for the physical, whereas the logical backup for taking it, then it won't be encrypted one, because the logical backup, it's kind of we are firing a read query and retrieving the data and store it in a SQL file. So logical backup won't be encrypted, whereas physical backup can be taken as an encrypted with the using the same encryption. So, what are the standard practices that we can implement to avoid any data breach? Means we can restrict the host level access entirely to the team or the who won't require the host level permission if they are only going to read from the direct MySQL. And keyring can be stored in a different path, and that path can be isolated with a limited number of access only can able to um, go and manage the file at that particular partition or the folder. And frequent keyring rotation also will be helpful. So even though it has been a breach, this new keyring will ensure that the data they can't retrieve it. So and even if some team need to have host level access, then we can restrict instead of access, we can reduce the privileges that we are assigning to the particular user. So as a operational consideration, so to enable the log file or to disable it back, we don't require any restart. It's a dynamic one. And if we are going to build up already any existing HAs there, like reader or replica, when we are adding one more reader or replica, we need to ensure that the new instance is also using the same encryption file as the source one. And when we are implementing this strategy, we need to first test it properly on the test environment, then create the enable the encryption on the low priority tables, and monitor the performance how it is, because when we are enabling the encryption for the larger tables, so the time taken for enabling the encryption also will be higher, and since it need to be encrypted and stored in the disk, so the performance can be varying. So once it is implemented, we need to monitor how is the server performance. So what are the performance can be deviated? Means like the CPU usage can be varying. The additional IOPS usage will be occurring on the server, because it need to encrypt as well as decrypt. Then the commit latency or the light workload deviation can be occurring, because both it need to encrypt and then encrypt it. So it is first recommended to have a proper testing at the any QA environment or UAT. So in that we can enable the encryption, and we can point our test application over the Q environment where the encryption is enabled, and stimulate the same workload as the protection. So if we have stimulate, so we can able to identify that what are the performance impact is happening, whether it can be uh, optimized further to reduce it, or is the latency of the deviation is within the acceptable range. So all this can be brainstormed at the QA before implementing it on the prod server. So here are the few examples. What are the metrics deviation can be? So like average query latency can be deviated, and commit latency can be deviated, because when it is when it is fetching the data without encryption, it will be faster, because there is no need of decrypting the encrypted data at the memory level and deliver it. So whereas in the encryption wise, this overhead will be added. And in case of any commit latencies happening on the server, because it need to be properly encrypted and stored in relay, bin log, and need to be transferred to the relay log. So this can cause a commit latency on the server, and which will indirectly trigger the thread activity. So these are the like dashboards that we need to look into it post enabling the encryption. So how we can rule out one by one means, so first we need to enable the keyring component on the server. Then we need to, as a standard practice, enable the default tablespace encryption, so which will ensure that the upcoming all the create statements are properly encrypted tables. And then we can move on to the enabling of encryption to the existing tables, and move on to the log file encryptions. Later, once all this has been settled out, then we can move on to the standard practice of rotating the keyring of like the master key on a periodic basis. So what are the common mistakes can be happen? So once the encryption is enabled, the directory is so sensitive. We need to maintain the proper permission that no one is able to accidentally delete it or remove. So like losing of this keyring is equivalent to non-retrievable data. So the data, even though it is there, if we have removed it, then it will become an useless. So unless if we are having any HA, then we can able to easily get the file like encrypted file from other server to paste it over here and start the service back. Whereas if it is a standalone server and the data encryption has been done on it, and we have lost the encryption key means, and then we can't retrieve it. The only possibility is if we have taken a proper standard practices of a backup on daily basis. Along with the backup, if we have backed up the encryption key also, only by that we can able to retrieve it. And in the backup also, if we have has been taken without proper encryption key means, then during the restoration we can't restore it. Then once it has been encryption is implemented on the direct production without having a proper QA testing, then we need to be fixing any performance deviation or issue which is lively occurring on the production server. So it is recommended to have the proper QA testing at first before implementing it on the production. And the proper SOP need to be prepared and maintained. In case if we lost the key, what are the steps need to be followed? In case if the data directory has been removed, or the encryption file has been removed, what are the strategies that need to be followed? How to restore the rebuild the entire server from the backup? All these steps need to be have a proper documentation to have a immediate fix for it. If not, like the proper HA need to be maintained. to have a immediate switchover in case if anything goes out of situation on the current primary or the source server. So as a takeaway of this presentation, we have gone through how to enable the encryption on both 8.0 and 8.4. Then what are the types of encryption can be enabled, and how to rotate the key properly on the environment, and what are the standard practices that we need to maintain it before and after implementing. Thanks, everyone.
So thank you, Praveen. That was an incredibly thorough presentation on MySQL encryption. So we have a few questions coming in from the audience. Let me read that out for you. We have a question from Prakash. It is like, will there be any performance degradation?
Yes, there will be a not drastic one if it is, but there will be definitely a deviation will be there on the CPU or at the IOPS or at the latency. Definitely there will be a deviation, but it's based on how much of a record that we are retrieving or inserting. If it is going to be a bulk transaction of the writes on the server, then the latency will be varying. It's but deviation will be there. It's based on the transaction size that we are maintaining.
Thanks, Prakash, for your question. Thank you, Praveen, for the answer. And we have a couple of questions from Deepak. Deepak, if you can unmute from your side and you can ask your question straight away to Praveen.
Yeah, hi everyone. So I have a couple of questions like how to generate this key and how we can onboard this key in the MySQL server.
So first we need to go with the sequence that we first we need to enable the component CNF. So under empty data file need to be enabled, and the CNF file and the startup file need to be properly created on the server and do a restart, which will enable the component automatically. By that we can enable the encryption, but assume as the alter table to enable the encryption of the larger tables will create a lock. So instead of doing directly on the production, you can create a parallel environment and have an encryption over there, and once it is done, you can perform a switch over, which will avoid your application locking, as well as the parallelly our environment setup also will be ready with the encryption, so we can easily do the switch over, which will avoid this locking or the production down issue. And so if we are having the physical migration, right? So at that time, definitely the same key need to be encrypted. Then only the proper decryption can be done while starting up the server. So both the source as well as the replica server need to have the primary. It's not only for the source and replica. When we are having a group replication or InnoDB clusters also, the primary and secondary server should have the same master key.
Okay, thanks, buddy.
Thank you, Deepak. Thank you, Praveen.
I have a question, Asha here.
Yeah, hi, Asha.
Hi, Praveen. So this says that this can be doable on Community Edition as well. So is it something that works on Community, or is it something to do only on the Enterprise Edition?
So whatever the possibility that I have mentioned this specifically for the community only. For the enterprise, we have here we can encrypt it using only AES method for the encryption. Whereas in community, 2 more encryption also available, and we can store the encrypted file in cloud also. The rotation also can be automated. So all these extra features are available in the enterprise, but the current presentation has been showed the commands and everything is based on the community action.
Thanks, Praveen.
Hi, Prashant.
Hi Praveen, Prasad here. Just I have one question. Like MySQL 8.0, we already using the encryption. So if I upgrade to the 8.4, so what will be the major differences in this encryption side?
Okay, so if you have already enabled the encryption at 8.0 and you need to move to 8.4, means at that time you need to convert. There are certain inbuilt utilities or they. So by using that utility, you are existing, because in older 8.0 also keyring will be maintained in the file. So you can able to convert the 8.0's encryption key to 8.4 compatible master key file. So that a utility is available. So we can able to use the same encryption key for the same encryption of 8.4 key to the 8.0 key to the 8.4 as well.
Thank you.
Thank you, Asha. Thank you, Prasad, for your questions. All right. It looks like there are no questions at the moment. That brings us to the end of today's webinar. Looks like everything was clearly covered in the webinar. So thank you for your active participation, and thank you for those wonderful questions and brilliant answers. If you have any questions come up later, please feel free to reach out to us. We'll be happy to help. And you can also reply to the follow-up email or reach out to us on LinkedIn, and we will be happy to respond. So as we wrap up our 50th webinar, right, I want to thank Praveen for the brilliant presentation, and all of you for being part of this journey. Be sharing the recording and the presentation slides with your registered email ID in the upcoming week. Please follow Mydbops on social media for upcoming webinars and database insights. And if you're looking to implement these security measures, or if you're planning a migration to MySQL 8.4 LTS, our consulting team at Mydbops is here to help. And you can reach out to us through our website, mydbops.com. Thank you once again for making our 50th webinar a success. And we will see you at MyWebinar 51. Have a great weekend. Thank you.